We're at lecture part 5 and we're looking at calculating suspensions or ingredients for suspension using master formula. So get right into it. So we look at this prescription here and we see a couple of things. We see the product formula, which is nifedipine oral suspension. It has nifedipine 500 milligrams, benzoic acid QS, syrup QS, purified water QS for 100 mils. That is what we would deem as the master formula. We have the available stock items. Of course, you're going to have purified water as one of the stock. And we have compounding notes. And this is what we're speaking about in terms of compounding notes, the amount of preservative you need and the concentration and the syrup at what concentration then you'll choose, because the benzoic acid and syrup has QS, meaning that you're going to add sufficient amount. But you as the compounder will know what that sufficient amount is. And of course, we have the prescription on the other side. Of course, we're going to assess the prescription for many things. We're going to look at the name of the person, the age of the person. This one gives a diagnosis, so it will give the compound if it's a pharmacist to determine whether or not this is appropriate for that particular diagnosis. The weight of the patient, that is the patient parameters, and the date the prescription was written, the date the prescription was written. What is requested in this case? Nifedipine is requested. The signatura we're going to interpret to mean 0.5 milligram per kilogram. That means every kilogram pound, the patient is to get 0.5 milligrams of nifedipine. TID, which is 3 times a day by mouth for a month. The doctor's name and signature and registration number are already present on the prescription, making it a legal document. The first thing that should jump out at you is that the prescription is written for a month. We recognize that we have to make a suspension from the master formula of nifedipine oral suspension. So it means then that we cannot make or compound for 1 month supply. We're going to have to stick to the BUD requirement, which is maximum 14 days. So in this case, the patient will only receive 14 days supply and have a copy prescription written where the patient will be requested to return for the remaining 14 days. All right, so the question is saying, calculate the ingredients needed to prepare the following prescription using the available stock and the patient data provided. So we're going to interpret the signature, which we pretty much did. We know that the person has a weight of 34 pounds, so clearly we're going to have to calculate the pounds, the weight in kilograms, and that kilogram weight is going to determine the dose. And we know that it's given 3 times for the day for 30 days. Of course, we convert the pounds to kilograms, which is 15.45 kg, and the maintenance dose that we got is 7.72 milligrams when we multiply 0.5 milligrams per kilograms times the kilogram weight. Of course, we have to determine the BUD, and the BUD is 14 days. So no matter how long the doctor would write the prescription, we still have to maintain the BUD requirement, which is 14 days, because we cannot guarantee stability after 14 days. So the maintenance dose is going to be, for 14 days, is going to be 7.72 milligrams times 3 times a day for a day times 14 days. There's no alt day here, so we just calculate straight, and we got 324.55 milligrams. We're also going to be determining the source of the ingredient. When we look at the available stock listing, we find that the nifedipine powder, pure powder, is available. And therefore, from that, we can now determine the volume. The volume can be determined from the master formula, in that we know what volume of suspension the nifedipine will be contained in, based on the master formula, which would have been 500 milligrams in every 100 mils. But we are not making 100 mils clearly, because we are using 324.55 milligrams. So therefore, the amount of suspension would be 64.91 based on the calculations there. So the total concentration is going to be 64.9 milligrams. And from the master formula, we are going to calculate the volume that the dose will be containing. Because if you're going to be writing a label, then you're going to have to determine what volume of the suspension will Tony Badal get or should be taking to get the 7.72 milligrams. And of course, we're going to get this from the master formula. If there was no master formula and you were told what volume to make, then you will have to get the volume of the dose from that. Most likely, if you're going to be determining your own concentration, then you will most likely be putting the dose in a particular volume. But in this case, we have a master formula and we have to use the master formula to determine the volumes there. So here, Badal is going to be taking 1.5 mils that will furnish the 7.72 milligrams of the drug, which is the single dose. Because we know that we are going to be making 64.9 mils, which is around about 65 mils of suspension, we have to determine how much benzoic acid we need to make that 65 mils preserved long enough to last for 14 days. We recall that benzoic acid is used at a concentration of 0.1%. So that means the final preparation must contain a concentration of 0.1% benzoic acid. We determine that if 0.1 is in 100, then the amount in 64.9 would be 0.0649 milligrams. Sorry, grams, not milligrams. And because we are not using the pure powder, we have to determine how much of the stock will furnish that amount of benzoic acid. And the stock we have is 5%, and the amount of volume of that 5% that will give us that amount of benzoic acid we need would be 1.3 mils. Similarly, syrup is calculated at a dose range of 10 to 30%. We are using 10%, so the amount for the 65 mils of suspension is going to be 6.5 mils. So your new formula is going to look like this. And of course, water is added up to 64.9 mils, and that would have been your suspension. And you would write on the label that the person is to be given, not take, because it's a 2-year-old. It would be very interesting to see a 2-year-old taking their own drug. But most likely the parent or the caregiver or whoever, the nurse, the child is in the hospital, will be giving the child 1.5 mils based on the concentration of the suspension. So when you're using a master formula, you are given the listing of drugs that must be in the formulation. That's one. Other master formulas may have the exact amount of benzoic acid to use. They may say benzoic acid 5%, 1.5 mils. So all you do, you just go and measure the 1.5 mil. But in this case, you're calculating it because it says QS, and the understanding is that the compounder will know that that QS must add up to a concentration of 0.1% in the final formulation. Similarly for the syrup. So that's how you do, that's what you do if you have a master formula. Generally speaking, in practice, you make your own master formula. You determine what the concentration will be. You will determine where your source of the active ingredient will come from, where it will come from, whether it be a pure drug or it's from tablet or capsule. You'll also determine what preservative you're going to use. Perhaps you won't use benzoic acid. Perhaps you'll use a combination of propyl and methyl parabens. Who knows? You are going to be the one to determine how you're going to make your product. Therefore, you'll be designing your own master formula. If you work in an organization that does a lot of compounding, they may have in-house master formulas already based on the popularity of the compoundings that they will do, or the compoundings that they most commonly do. They may have a formulary in their own institution that you will follow, and they will have their own master formula. So it all depends on where you are and what the nature of the compounding will look like.